Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, in this video we are going to discuss a few questions from the list of the tutorial in our tutorial book. Hopefully that this can help you to continue with the rest of the questions from the tutorial collection of questions, and also with the collection of past year question in your book. So let's begin the discussion here now. Okay, so first one here, I don't think that we're going to discuss question number 2 because related with the topic of limits and continuity. So I'm just looking at the question number 1 for this part here. Now let's continue with question number 1a. Okay, y equal to 3x squared plus 4. Okay, now find dy dx using the first principle. In this question, we are going to find out y prime or dy dx using the first principle, which is limit of h approaching to 0 of x s plus h minus fx divided by h. We may find that, we may write down here y prime according to this 2 times 3 equal to 6x and differentiate 4 equal to 0. Class, we cannot simply write down the y prime or dy dx equal to 6x from this function because we need to find a dy dx using the first principle. But then y prime for this as a reference. This is the final answer we should get at the end of the solution here. Okay, so let's begin the step here now. Limit h approaching to 0. Okay, fx plus h, meaning that we substitute x with x plus h. So then 3x plus h squared plus 4 minus fx, which is 3x squared plus 4 and divided by h. Okay, look at this one here now. X plus h in bracket square. So let's find the expansion of this. X plus h square equal to x squared plus 2xh plus h squared. So 3 multiplied with every single term here, the expansion of x plus h squared, with a limit of h approaching to 0, 3x squared plus 3 times 2xh, 6xh plus 3 times h squared, 3h squared plus 4, minus with negative 3 times x squared, negative 3x squared minus 4, and divided by h. Okay, so let's simplify one by one. 3x squared minus 3x squared, 4 minus 4. Okay, so we get h and h squared here. H and h divided by 1 of the h here. So h, 1 of the h, and h. So limit of h approaching to 0. What we have here right now, 6x plus 3h. So then, substitute h equal to 0 here with 6x plus 3 times 0. And it is equal to 6x. Okay, so this is our reference and we get exactly the same as this one, y prime. Okay, equal to 6x. Question number B. Y equal to 2 square root of x plus 1. X plus 1. So then y prime equal to limit of h approaching to 0, 2 square root of x plus h. Okay, function of f with variable of x plus h, so that x plus h plus 1 minus fx to square root of x plus 1, and everything divided by h. Okay, class. If I simply substitute h equal to 0 here, so everything divided by 0, so it's meaningless. Even h 0 here, so square root of x plus 1, 2 square root of x plus 1 minus 2 square root of x plus 1, 0 over 0 are divided. So what can we do here now is 2 square root of x plus h plus 1 minus 2 square root of x plus 1 divided by h. And we are going to multiply, okay, refer to the numerator here, then we multiply with the conjugate, which is 2 square root of x plus h plus 1 minus, okay, minus, they come up with plus, okay, sorry. Plus with, okay, 2 square root of x plus 1 divided by 2 square root of x plus h plus 1 plus 2 square root of x plus 1. Okay. So then 2 times 2 equal to 4. Okay. Class, the existence of conjugate here is because if we substitute h here, then we get 2 square root of x plus 1 minus 2 square root of x plus 1 equal to 0. And h, 0. 0 over 0 is undefined, meaningless, so we avoid that. So right now, 2 square root of this multiplied with 2 square root of this one here, x plus h plus 1. 4 square root times square root, then equal to 1, x plus h plus 1. Then 2 with this one here positive, then 2 with this one here negative, okay, 2 with this one and 2 with this one negative and positive cancel each other because it's a conjugate. Then negative times positive, negative, 2 times 2 equal to 4, square root of x plus 1 multiplied square root of x plus 1, then x plus 1. Divide by, okay, it is h here, and then multiply with this one, 2 square root of x plus h plus 1, plus with 2 square root of x plus 1. Okay, before that, I forgot, just now I show you the y prime as our reference. I forgot, recall to show you this part here, but it's okay. Limit of h approaching to 0, 4x plus 4h plus 4 minus 4x minus 4 divided by h, 2 square root of x plus h plus 1 plus 2 square root of x plus 1. Okay, I bring it up here. Never mind. Now, 4x minus 4x, 4 minus 4. So then h divided by h. So what's left here now? Limit of h approaching to 0. What's left on the top here? It's only 4, right? 4 divided by 2 square root of x plus h plus 1 plus 2 square root of x plus 1. Okay, substitute h with 0 here. Then, because we already substitute h with 0, so we have to write down the limit of h approaching 0 here. It's just now 4 divided by, okay, x plus square root of x plus 1. 2 times square root of x plus 1. And 2 times square root of x plus 1. We come out with 4 square root of x plus 1. Then divide by this, come out with 1 divided by square root of x plus 1. Okay, so I show you the solution for question A and B. Then you may continue with the, please continue with the question of C and D and question number 2. Okay, let's take a look at this question now. Differentiate the following with respect to the x. Okay. Question number 3a. Fx equal to 2x cubed. 2x cubed plus 3x squared minus 1. Okay, so then f prime or dy dx, 3 times 2 equal to 6x squared. 3 times 2 equal to 6 and 3 minus 1 equal to 2. 2 times 3 equal to 6x. So we factorize this, simplified as a 6x, then x plus 1. Okay, I don't think I'm going to discuss all the question one by one, but let's see which example that a little bit different from others. Let's say C. Okay, question C, y equal to negative square root of x plus x to the power of negative 4 over 7 minus 4 divided by x cubed. Okay, before we derive or differentiate, let's simplify this. Negative square root of x plus x to the power of negative 4 over 7 minus 4 divided by x cubed. Let's make it like this one and bring this above, come out with x power of negative 3. Okay, so then y prime or dy dx equal to, this is square root means x power of half. So then differentiate this, half times negative, negative 1 over 2, x to the power of half minus 1, negative 1 over 2. Negative 4 over 7, bring up here, minus 4 over 7, x to the power of negative 4 over 7 minus 1, negative 4 over 7 minus 1 or minus 7 over 7, negative 11 over 7. So negative 11 over 7. Okay, negative 4 over 7x, negative 11 over 7, and then negative 3 times negative 4, positive 12x of negative 3 minus 1, negative 4. Okay, so negative 1 over 2 square root of x, and then negative 4 divided by 7x to the power of 11 over 7 plus 12 x power of negative, so x to the power of 4. There you go. Okay, then next question. What about this one here now? No. Okay, question E. Y equal to square root of x, then x squared minus square root of x. Square root of x and square root of x means that x to the power of half. So then this one, x power of 2 plus 1 over 2. Just imagine that 2 here is 4 over 2. 4 over 2 plus 1 over 2, 5 over 2. Then minus with x power of half, square root of x times square root of x, half plus half equal to x to the power of 1. Then y prime equal to, this is 5 over 2, 5 over 2, x to the power of 5 over 2 minus 1, then power of 3 over 2 minus 1. Okay, and then next question I, y equal to 2 plus x squared to the power of 3 over 4. Then y prime equal to, okay, for this question, we are going to differentiate the power outside here, come out with 3 over 2 to the power of 2 plus x squared. 3 over 2 minus 1 or 3 over 2 minus 2 over 2? 1 over 2. Multiply with derivative of the 2 plus x squared, differentiate function inside, differentiate 2, 0, differentiate x squared times 2x. So 2 divided by 2, that is equal to 3 times x. Then 2 plus x squared to the power of half. Class, I found that my working solution and final answer is correct, but then I make a mistake. We call copying out the question here is 2 plus x squared in bracket of 3 over 4, and I make it here is 3 over 2. So the solution and final answer is correct, but then the question is incorrect. Never mind. I'll do it again for question number I. Question number I, which is y equal to 2 plus x squared to the power of 3 over 4. Then y prime equal to the differentiate of the power above here, outside, 3 over 4. Then 2 plus x squared. Over 4 minus 4 over 4, negative 1 over 4. Okay. So the rules of differentiation, we are going to differentiate from outside to inside. So what's the outside term here, we call the index or power 3 over 4, we already done it, 3 over 4, and then 3 over 4 minus 4 over 4 minus 1 equal to negative 1 over 4. Then don't forget, we need to multiply with the derivative of the function inside here. Differentiate 2 equal to 0, x squared equal to 2x. Okay, so 2 and 4 here become 2. Then power of negative, so 3x over 2, 3x divided by 2, and then 2 plus x squared to the power of 1 over 4. Okay, I'm sorry for the mistake then. So that's solution for question number 3. A few questions from collection of 3 here. So let's take a look at question number 4. Okay, question number 4. Then I choose the first one then here. fx equal to x minus 1 cube multiplied with x plus 2 to the power of 4. Okay, multi-product rule between these two functions of x minus 1 cube and x plus 2 to the power of 4. Let's make this one as a u and v. Okay, so f prime x equal to u prime dot v plus u dot v prime. Okay, the proper one in the book is v prime u plus u v prime. Still the same. So then, okay, u prime, let u equal to x minus 1 cube and v equal to x plus 2 to the power of 4. Then u prime equal to 3x minus 1. 3 minus 1 equal to 2. And differentiate x minus 1, differentiate multiply with 1, then 3x minus 1 squared. Then v prime, differentiate 4, x plus 2, 4 minus 1 equal to 3 multiplied with derivative of x plus 2, differentiate x, 1. Then 4x plus 2 cube. Then now substitute here u prime, which is 3x minus 1 square u prime and v equal to x plus 2 to the power of 4 plus u x minus 1 cube multiplied with 4 here and x plus 2 to the power of 3. Okay, then now 3, it is now 3x minus 1 square and x plus 2 to the power of 4, then 4 here plus 4 x minus 1 cube and x plus 2 power of 3. Okay, we call factorize this for x minus 1 square and x minus 1 cube. So we only take the lowest one, which is x minus 1 square, x minus 1 square, multiply with x plus 2 power of 4, x plus 2 power of 3. So we factorize with lowest in here, x plus 2 power of 3, then 3. X minus 1 square, both have been factorized, taken outside here, so multiply with 1, and then x plus 2 power of 4, take 3 have been taken outside, so they come out with x plus 2, plus with 4, x plus 2 cube, and cube is all have been taken outside, then x minus 1, 3, 2 will be taken outside, so then x minus 1. There you go. Okay, this is for question number 4A. 5 for B. Okay, B, fx equal to 3x plus 1 to the power of 5 divided by 2 minus x to the power of 10. Okay, u equal to 3x plus 1 to the power of 5 and v equal to 2 minus x to the power of 10. Then u prime equal to 3x plus 1 to the power of 4, and don't forget we need to differentiate the function inside. Differentiate 3x plus 1 multiply with 3. It is equal now 5 times 3, 15, 3x plus 1 to the power of 4. Then next, v prime equal to we call differentiate the power of 10, then 2 minus x to the power of 10 minus 1 equal to 9, multiply with differentiate of 2 minus x equal to negative 1, so negative 10, 2 minus x to the power of 9. Okay, now f prime x equal to u prime dot v minus u dot v prime divided by v squared. Okay, substitute 1 by 1 u prime here, 15 3x plus 1 to the power of 4 multiplied with v 2 minus x to the power of 10 minus u 3x plus 1 to the power of 5 and v prime negative 10 2 minus x to the power of 9 and everything divided by v squared. Where is v? 2 minus x to the power of 10 squared. Okay, so let's simplify this one here, which is 2 minus x to the power of 20. It's really 20 here. Okay, now, okay, look at this one here, because the denominator is only for 2 minus x. Now, 2 minus x power of 10, power of 9, power of 20 is just like b power of 10 minus b power of 9 divided by b power of 20. Okay, how do we solve this? if we divide B10 with B20, cut all the 10 and 20 minus 10 equal to 10, but list here is only 9. So it means that here we can only divide by 9, I think so. So come up with 11. Then cut everything here, and this one come out with 20 minus 9 equal to 11. 10 minus 9 equal to 1. Sorry, actually that here. Okay. So now 15, 3x plus 1 to the power of 4 times 2 minus x to the power of 1 minus 3x plus 1 to the power of 5, negative times negative positive. Negative times negative positive, 10, 3x plus 1 to the power of 5, and then this one here, everything and being equal, divide by 20 here, so nothing left, and everything divide by 2 minus x to the power of 11. Okay, for this question, is it possible for us to factorize another part here? Okay, I think that I stop here, but then if you find that we can continue with 1 or 2 steps to simplify this, then you may recall continue it. Okay, now for question 4, which I think that these 2 questions are more than enough, because okay. Okay, class, for question of D, okay, treat this like you recall, we solve question number 4a, product of the recall between these 2 functions. Okay, just imagine that if y equal to 1 plus x to the power of half multiplied with 1 minus x to the power of half. So this is our u and this is our v for question D. And for this one here, it is x minus 1 to the power of half divided by x plus 1 to the power of half. So for question of F, please refer to question of 4b here. Yeah, it's still the same thing. Okay. Okay, now question of 4g, number 4g. 4g, okay, y equal to 2x squared divided by 2x minus 1 and x plus 1. Okay, since that between these 2 factors, 2x minus 1 and x plus 1, there is no power here. So let's say if I make this one as simplify this, 2x squared divided by 2x squared, then 2x minus x equal to an x, negative 1 plus 1 minus 1. So this is our u and this is our v, where u equal to 2x squared and v equal to 2x squared plus x minus 1. So then u prime equal to 4x and v prime equal to 4x plus 1. Then y prime or dx, yes, u prime 4x and v 2x squared plus x minus 1 minus u 2x squared and v prime 4x plus 1, and everything divided by v squared, v 2x squared plus x plus 1, or no, minus 1. minus 1 in bracket square. Okay, so you may expand this. 4 times 2, 8x cubed plus 4x squared minus 4x, then minus 2 times 4 equal to 8x cubed, and then minus 2x squared plus 1 minus 2x squared, and everything divided by 2x squared plus x minus 1. 8x cubed minus 8x cubed, 4x squared minus 2x squared equal to 4 minus 2, 2x squared minus 4 divided by 2x squared plus x minus 1. Okay, square here. Is that it? I think so. Wait a minute. 2x squared minus 4 from 2x squared minus 4, which is 2x squared minus 2, then 2x minus 2 and x plus 2x squared and then minus 4. Okay, this one should be square root of 2 and square root of 2. Okay, not match with this one, so that's it. Doesn't match that we can recall. Divide by the same factor. Okay, question number 4G. Okay, question 5. Now let's take a look at question number 5, where y equal to ax squared plus b over x. Okay, class, sometimes that for this kind of question, prove that this we call this question here. Yeah, maybe for some students, they list down the y prime and second derivative, and then substitute into this here and here, then make it equal to 0. Okay, let's try this one here now. So y prime or dy dx. Differentiate this. Ax squared 2ax, and this one here ax squared plus bx power of negative 1. So negative 1 times positive minus 1 bx power of negative 2. Then next, differentiate the dy dx, derive the dy dx, so then we come up with second derivative of y respect to the x. Again, derive this, differentiate this, x, then come up with 2a, negative 2 times negative positive 2 bx power of negative 3. And then 2a plus 2b divided by x cubed. Okay, now, sometimes we need to think, might be a few ways of getting this solution for this question. Let's say before that, and this term equal to second derivative of y respect to the x. Okay, now let's say if I multiply with x squared here, multiply with x squared and multiply with x squared, what's going to happen then? X squared divided by x cubed. Okay, there's only one x left in here. Then x squared second derivative of y respect to the x equal to 2ax squared plus 2b divided by x. And what we have here right now, it wanted in the term of x squared second derivative of y respect to the x equal to 2y. Okay, 2 and 2. Factorize this. 2 and ax squared plus b over x. And this is x squared second derivative of y respect to the x. Okay, x squared second derivative of y respect to the x is all here. And 2, and look at this one, y. What is the term of y here just now? Ax squared plus b over x. Ax squared plus b over x. There you go. Okay. Get it? Okay. Question number 6. Question 6. Okay. In this term, okay, question number 6. In this term, we got y equal to e to the power of fx. So then, y prime equal to f prime x multiplied with e to the power of fx. So means that differentiate the function above that we call the power of e, the constant of e, bring up here f prime x multiplied with e fx. So the first question here now, 6 equal to fx equal to e to the power of 3x. So then f prime x equal to, differentiate 3x, 3e power of 3x. Okay, I'm not going to show you all. We're going to choose, okay, B, okay, not B, C. Y equal to 10 to the power of 3x. What's the difference between the constant of e and 10? Okay, because the constant of 10 here, we're going to differentiate this, and then actually there is a term of ln e here. Okay, but since that because it's equal to 1, then only 3e power of 3x left. So for this one here, y prime equal to 10 power of 3x natural log of 10 multiplied with differentiate of 3x equal to 3. So 3 multiplied with 10 power of 3x and natural log of 10. As I mentioned just now, actually that we have ln e, but since the ln is a log e to the base of e, it's just like log a to the base of a, which is equal to 1 because a to the power of 1 equal to an a. So this is also equal to 1 because e to the power of 1, which is equal to e, constant of e then. Okay, but since that here log 10 to the base of e, it's leave it just like that. Okay, then question number E. Question E. Y equal to 3 power of 9 plus 4x. Then y prime equal to, write down all this again, 3 power of 9 plus 4x, and then natural log of 3 multiplied with derivative of 9 plus 4x equal to 4. Okay, this 4 we can simply multiply with this 3 because this 3 has the index of 9 plus 4x and the base are not equal. So the best thing we can do here now is write down again 4 but put it in bracket, multiply with 3 to the power of 9 plus 4x and multiply with natural log of 3. Okay, choose another one to end up what you call the discussion for question number 6 with y equal to x multiplied with e to the power of 5x. So just imagine that this is u and this is v, where u equal to x and v equal to e power of 5x then u prime equal to 1 and v prime equal to 5e to the power of 5x. Then y prime equal to u prime dot v plus u dot v prime. U prime equal to 1 multiplied with v e power of 5x plus with u with x, and v prime equal to 5e power of 5x. And differentiate, we call factorize, simplify this, e power of 5x plus 5x e power of 5x. So look at this one here now. It has the same term, so we can recall factorize this e power of 5x 1 plus 5x. There you go. Let's take a look at the next question then. Okay, question 7. Question 7. Which one then? Okay, before that, for y equal to natural log of fx, so then y prime equal to derivative of ln, automatically it gives you 1 over. Okay, and then fx, then multiply with derivative of fx, which is f prime x. Okay, which I think that 3 example is more than enough for 7. Let's say question C. Okay. Fx equal to natural log of 3x squared minus 2, then f prime x equal to differentiate ln 1 over 3x squared minus 2, and then differentiate, multiply with the derivative of 3x squared minus 2, then come out with 6x. So simplify this, 6x divided by 3x squared minus 2. Question F. Question F. Fx equal to natural log of square root of 1 plus x squared, or is equal to natural log of 1 plus x squared. Square root means power of half, then bring half in between here, 1 over 2 natural log of 1 plus x squared. Okay, so this is the one that we're going to use. Okay, so f prime x equal to the 1 over 2, a constant, and derive, okay, the differentiate ln 1 over 1 plus x squared multiply with derivative of 1 plus x squared, 2x. So 2 divided by 2 equal to, we got x here, and divide by 1 plus x squared. Okay, question number 7, C and F. What about G? Okay, question G, fx equal to square root of 1 plus x divided by 1 minus x. Okay, and for this one here now, okay, okay, fx equal to natural log. Sorry for taking a long time. Okay, for this one here now, ln, let's take a refresh our memory about this. Y equal to natural log of we call a over b which is equal to natural log of A minus natural log of B. You still remember that? Log A plus log B equal to log A multiplied with B, and log A minus log B equal to log A divided by B. I do hope that all of you still remember this. And look at this one here now. So from here, you come out with natural log of square root of 1 plus x minus natural log of square root of 1 minus x. Okay, log A divided by B. Log, in bracket here, is actually that natural log of square root of 1 plus x divided by square root of 1 minus x. Log A divided by B. Log A divided by B equal to log A minus log B equal to log A minus log B. Okay, so then f prime x equal to, we're going to use this one here now. Derive ln, okay, but before that, this one here we will also derive, okay, square root of x means that natural log of 1 plus x to the power of half minus natural log of 1 minus x to the power of half. Bring this half in front here, 1 over 2 and also 1 over 2. Okay, so this is the one they're going to use here now. Okay, f prime x half 1 over 2, differentiate ln 1 over 1 plus x, and differentiate 1 plus x, derive the x equal to 1, minus 1 over 2, and derive ln 1 over 1 minus x, and derive 1 minus x, differentiate 1 minus x, negative 1. Okay, so come out with 1 over 2, 1 plus x, negative with negative, positive 1 over 2, 1 minus x. There you go. So class, for this one here now, you may recall, try to simplify this until get S1 here, 1 over 1 plus x and 1 minus x. Okay, try yourself how to simplify this one here. Then next, after question 7, let's take a look at question number 8. Okay, question 8. For question of 8, no, before that, fx equal to any, what we call, any trigonometric function here, let's say sine power of n, let's say gx here. So f prime x equal to, class, this is the first priority that we need to derive first, n. Now the power of this n is the first priority, then sine will be the second, and this function of gx will be the third. Things that we're going to differentiate. Okay, so differentiate 1 by 1. So then this one here, differentiate of n, and then sine of n minus 1 of gx, for example, multiplied with, just now we differentiate the power of n minus 1 and then differentiate sine, it gives you cos gx, and then differentiate gx, come out with g prime x. Okay, this example here. Question number 8, B. Question B, y equal to secant of 3x minus 1. So in this case, we differentiate the function outside to inside. Differentiate of secant is secant 3x minus 1. Please refer to the formula in your lecture notes then. The derivative of secant is secant and tangent. Tangent 3x minus 1. Okay, derive the secant, then you get secant and tangent. Multiply with, now we derive the function inside 3x. It gives you 3. So then 3 secant 3x minus 1 and tangent 3x minus 1. Okay. Question B and then E. Question E, y equal to cos of, square root of 4x plus 3. Okay, so y prime equal to, differentiate cos, it gives you negative sine square root of 4x plus 3. Okay, we derive the cos first, I give you negative sine. Now, derive the square root of 4x minus 3. Just imagine that this 4x plus 3 is a 4x plus 3 to the power of half. Then come up with 1 over 2, 4x plus 3 and half minus 1 equal to negative 1 over 2. And then derive 4x plus 3, differentiate 4x plus 3, it gives you 4. Differentiate 4x, it gives you 4 here. Okay, 4 divided by 2 equal to 2. Then you come up with negative sine square root of 4x plus 3. We got 2 here. Negative 2 sine 4x plus 3, and this one power of negative half, which means that it is square root of 4x plus 3. Okay, we cannot simply divide 4x plus 3 with this one here because this is an angle for sine and this is square root of 4x plus 3. There are two different things here. Okay, you don't simply divide this and you get negative 2 sine power of 1. No. Okay, this up. Okay, question F. Question F, y equal to tangent cube of 1 over 2x. Okay, now for this one here now, this is the first thing that we're going to derive or differentiate, and tangent will be the second part, and this one here, third part. Okay, so now y prime or dy dx means that we differentiate this 3 tangent squared 1 over 2x multiplied with, we derive the we call the index of power here 3 and 2, and now it's time for the tangent. Tangent, differentiate of tangent, secant squared 1 over 2x multiplied with differentiate of 1 over 2x half x equal to 1 over 2. Okay, now 3 times half, which 3 over 2 multiplied with tangent square 1 over 2x and secant square 1 over 2x. Okay, try with another question here. Okay, G. Question G, y equal to, question of G here, y equal to e power of 2x multiplied with sine 3x. So this is our u and this is our v now, where u equal to e power of 2x, v equal to sine 3x, then u prime equal to 2e power of 2x, v prime equal to, derive the sine, it gives you cos 3x, and differentiate 3x, it will give you 3 or 3 cos 3x. So then y prime equal to u prime 2e power of 2x multiplied with v, which is sine 3x, plus with u e power of 2x and multiply with v prime 3 cos 3x. Okay, this is sine and it's a cos here, so we cannot factorize, but we can look at this one here, e power of 2x and e power of 2x. E power of 2x where 2 sine 3x plus 3 cos 3x. Okay, so that's the solution for question number G. Okay, for question number 9, proving the question again, so I leave it to all of you for you to try. And now let's take a look at question number 10. Okay, question number 10. Differentiate implicitly with respect to the x. Okay, so for question A, for example, x squared plus y squared minus 4x equal to 0. So we're going to differentiate one by one here. Okay, x squared plus y squared minus 4x equal to derive of this 0 respect to the x. Okay, because we differentiate x respect to the x, so for x squared we just differentiate as usual to x. But for this y, differentiate y squared respect to the x, we derive as usual, as normal first, derive y squared, it gives you 2y. But then because we differentiate y with respect to the x, then we write down dy dx. Minus derive 4x and it gives you 4. And differentiate 0, 0. Okay, now the process is we leave the term with dy dx on left side and bring out the term without dy dx to the other side. So now 2y dy dx equal to, this is minus 4. So bring up here 4 minus 2x. And dy dx equal to 4 minus 2x divided by 2y. Okay class, for this one here we can simplify this, divide by 2 every single of this, divide by 2, divide by 2 and divide by 2, supposedly then here 2 minus x divided by y. That's it. Okay, question C. So let's choose question C. Number 10C. Y squared with an x plus e power of 2y x cubed plus 2y equal to negative 4x. Okay. Okay. So this is a question of C. Y squared, or question E, sorry. This is a question of E. Y squared x plus e power of 2y x cubed 2y and minus 4x. Okay, so differentiate this respect to the x and also here respect to the x. Okay, now we solve this slowly one by one. For y squared and x, there are two terms, y squared and x. So first, let's derive the y squared. It gives you 2y. And differentiate 2y, x. Okay, we just copy that all again. Because we derive the 2y, y squared become 2y. We derive the y respect to the x, then come up with dy dx. Just now we derived the y squared, so we got 2y, and because it y, differentiate y respect to the x, then we write down dy dx, plus with, now it's time for x, derive the x, differentiate x, 1, multiply with y squared. So u prime v plus u v prime is only that because we derive the y respect to the x, so 2y dy dx. X just following here. Okay, now plus with, according to the question of this, question number 10, y square and x, and then e power of 2y x cubed again. E power of 2y multiplied with x cubed. So we are derive one by one. This first. Differentiate e power of 2y to e power of 2y, then x cubed, and because we derive this y respect to the x, so then multiply with dy dx. And then differentiate x cubed plus with 3x squared, and then e power of 2y plus with derive the 2y, then come out with 2, and because we derive y respect to the x, then come out with dy dx equal to derive negative 4x, come out with negative 4. Okay, so look at this one here now. We got this with dy dx, we get this with dy dx, and we got this with dy dx. So that the term with dy dx, we put them all together on the left side, and the one without dy dx we bring to the other side. So then it is 2yx, 2xy plus with, okay, this one here now, x cubed 2e power of 2y plus with this one here is 2 dy dx. Then we got negative 4. Okay, now this one y squared here become minus y squared, and also here minus 3x squared e power of 2y. So now our dy dx equal to negative 3x squared e power of 2y plus y squared plus 4, and divide by all this one here, which is 2xy plus x cubed 2e power of 2y plus 2. That's it. Okay, class. I'm not going to show what we call the solution for question number 11 and 12, because we call what you need to solve this question is the basic of we call differentiate the x and y respect to the x. So once you know all these things, then you will you are going to implement it into the question of 11 and 12. So please, if you differentiate the term with y, okay, there's a term of y respect to the x, so derive it first, and then multiply with dy dx. Derive everything first with what we call e power of 2y. So 2e power of 2y, x cubed, we just following here, and because we derive the y respect to the x, then multiply with dy dx. And just like this one here, derive 2y, then equal to 2. But because we derive y respect to the x, then multiply with dy dx. Okay, so I do hope that all of you may try with the rest of the question. Here is just the same as this one here. No? Or should I? Okay, takes call time. Let's try. If I choose question number 12, let's see. Given y equal to, given y sine x equal to e to the power of x. Okay, so we're going to prove that the second derivative of y respect to the x plus 2 cotangent dy second derivative y respect to the x plus 2 cotangent x dy dx minus 2y equal to 0. So let's see if we can solve this one here now. So y sine x equal to ex. So we derive respect to the x and also here. So we got y and sine x. So we derive y first, differentiate y first. Differentiate y equal to 1 multiplied with sine x. And because we derive y respect to the x, then come out with dy dx. Plus with, just now we derived the y, right? You get 1 here. So it's time for sine x now. So y and derive the sine, it gives you cos x equal to, differentiate ex equal to ex. Okay, so then now simplify this, sine x dy dx plus y cos x equal to ex. So again, differentiate, derive everything here respect to the x. So now for this one here now, derive the sine, it gives you cos x dy dx plus with sine x, differentiate this dy dx, it gives you second derivative of y respect to the x plus with, okay, now derive the y equal to 1 and then cos x, and because we derive y respect to the x, it come out with dy dx, okay, plus with now y and derive the cos x, it gives you negative sine x equal to derive the ex equal to ex. Okay, so how are we going to compare this with this one here now? Okay, so what I get here now is second derivative of y respect to the x. What if I divide by, because what I have here now is sine x, second derivative of y respect to the x. So if I divide by sine x on left and right, and of course sine divided by sine equal to 1. So this is second derivative of y respect to the x. Okay, cos over sine is plus cotangent x dy dx, okay, plus with cos over sine equal to cotangent x dy dx, and sine x divided by sine x, negative with positive, negative, y sine divided by sine equal to 1, then equal to ex divided by sine x. So look at this two here now, second derivative of y respect to the x plus 2 cotangent x dy dx. Okay, the first part is already here now, then the second term is here. What else? Minus y. We got this and this, and then minus 2y equal to ex divided by sine x plus y. Or if I bring this one here, here become positive 2y, still the same. Okay. Okay, now from this equation, y sine x equal to ex, then y equal to ex divided by sine x. So this is our y, right? Y plus y. So then second derivative of y respect to the x plus 2 cotangent x dy dx minus 2y equal to 0. That's it. Okay, luckily I can solve this question. Next one. Okay, so parametric equation, question 13 parametric, question 14 parametric, and also question 15, which I think I choose. Okay, or one or two questions is more than enough. So I let all of you try the rest of the question, and please refer to my lecture note video of lecture note 10. So help you with the rest of the questions. So question 13. Find dy dx parametric equation when the value of t equal to 1. So question A here, x equal to 2t and y equal to t squared when t equal to 1. Okay, so then dx dt equal to, differentiate this to t equal to 2 and dy dt equal to, differentiate t squared equal to 2t. So then dy dx equal to dy dt multiplied with dt dx. So now we already have dy dt here, dy dt which is 2t multiplied with what we have here right now is dx dt, and what we want here right now is dt dx. So means that here this is 1 over dx dt. So dt dx is 1 over 2. So when dy dx when t equal to 1, which is t here, so it is 1. Okay, question 13a. Okay, means that here for dy dx equal to t and dy dx when t equal to 1, which is equal to 1 here. 13d. X equal to t plus 1 square and y equal to t square minus t minus 3. So then dx dt equal to, differentiate 2 t plus 1. Then 2 minus 1 equal to 1 and derive t plus 1 multiply with 1. Then 2t plus 1 and dy dt equal to, differentiate of derive 2t square equal to 2t. So then dy dx equal to dy dt multiplied with dt dx. So dy dt equal to 2t and then dx dt dx. And what we have here right now is dx dt. So dt dx, which is 1 over multiplied with 1 over 2t plus 1, or is equal to 2t divided by 2 divided by 2, so then come out with this one here. T plus 1. So for dy dx when t equal to 1, that is 1 divided by 1 plus 1 equal to 1 over 2. Okay, I think for this one I chose another question of 14 to end up discussion here. Number 14. Okay, we got x equal to 2 cos cube t and y equal to 8 sine cube t. So dx dt equal to, okay, this is okay 2 cos cube. Okay, so 2 and differentiate cos cube times 3 cos square t, and derive the cos, it gives you negative sine t, and derive or differentiate t, it gives you 1. So then 2 times 3 equal to 6 cos square t, and negative here sine t. Okay, 8 sine cube t. So then dy dt equal to 8. Differentiate the power of 3 here. 3 sine square t. Derive differentiate sine, it gives you cos t, and differentiate t, they give you 1. 24 sine square t cos t. Okay, now dy dx equal to dy dt multiplied with dt dx. So then dy dt, this is dy dt here now. Dy dt, so they come up with 24, okay, 24 sine square t and cos t, and multiplied with dt dx, this is dx dt, so come up with 1 over, so we just imagine that is a divide by negative 6 cos square t and sine t. Okay, sine square divided by sine, cos divided by cos square. 24 divided by negative 6, 24 divided by 6 is 4, negative. Sine over cos is tangent t. Okay, so dy dx equal to negative 4 tangent t. 24 divided by 6, 6 times 4, 24. So sine square, one of it with the sine here, cos with one of cos. And now, second derivative of y respect to the x equal to, we are going to recall d dt. Just now, this is the recall the chain rule of this dy dt. Look at this one, differentiate y respect to the t. So at this moment here now we differentiate again, okay, but at this time we derive the dy dx, replace the y here, so which is dy dx. So dy dt, by this moment the y is dy dx, not y anymore, but we still use the same chain rule of this one here. Multiply with dt dx. dt dx, okay, so look at this one here, dt dx. Yet, we still same here, dt dx, we can refer to the dx dt. So let's find out now, derive of dy dx, which is this one here, negative 4 tangent t. Negative 4, derive the tangent secant square t, and derive the t, it gives you 1. So negative 4 secant square t. Okay, now the differentiate dy dx respect to the t is negative 4 secant square t, and dt dx, which is one here, 1 over negative 6 or 1 over negative 6 cos square t sine t. Okay, and what about this one here now? If I bring up here, you come up with negative 4. Secant, okay, secant is 1 over cos. So secant squared t, which is 1 over cos squared t. 4 secant squared t, and this is 1 over negative 6. And 1 over cos squared is another secant squared t, and multiplied with 1 over this one here, negative 4 secant squared t, multiplied with negative 1 over 6, 1 over cos squared t, and 1 over sine t. So, negative 1 over 6, negative 1 over cos is secant square secant is 1 over cos, and 1 over sine is cosecant t. Negative 4 divided by negative 6, negative 4 over 6, 2 over 3, secant squared times secant squared, secant power of 4 t, and cosecant t. Okay, so this class, I do hope that this explanation of more than 1 hour helps you to continue with the rest of the question for tutorial 9. And that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.